Alright, so in this exercise what we're trying to do is trying to find all of the zeros of this cubic function given that f of 7 is equal to 0. In other words, 7 is a 0. If I were to divide this function by x minus 7, I'd get 0 as a remainder. So let's go ahead and divide that out by synthetic division. Put 7 outside the box, and then the coefficients across the top. I got 10, negative 81, 71, and 42. Since I'm not missing any terms, bring down the 10, multiply it times 7, and add them up. I get negative 11. Multiply it, negative 77, add it, negative 6, multiply, negative 42, and sure enough there is a remainder of 0. So now this that's left over is quadratic. It's the quadratic 10x squared minus 11x minus 6 equals 0. And now we're just going to try to solve that. I'm going to factor that. Open up parentheses. Let's try guessing and checking. So this times this must equal 10x squared. Let's just try, say, 2x and 5x. And these two multiplied together have to be negative 6. And when we're all done, they have to add up to negative 11. So let's try a 3 and a 2. So from the inside product, we've got 15. From the outside product, we've got 4. And if I subtract those, I would get negative 11. So the 15's got to be negative, positive. There we go. So now getting our zeros from this, we have x equals, from the first one, add the 3 over, divide by 2, 3 halves. Second one, subtract the 2 over, divide by 5, is negative 2 fifths. And then of course I have my original 7. Okay. So what you got to realize here, of course, is that I was already given a 0. And that's kind of an unusual case. What I'm usually having is just the function and nothing else, and then I have to try to find all the zeros. So there's something that'll help us do that. It's called the Rational Zero Theorem. So let's look at this example. Look at the all of our zeros written as rational numbers, written as fractions. Okay, so now look at all of the numerators. I got a 7, I've got a 3, and I've got a 2. If I multiply all those together, I get 42. Those are all factors of the constant term. Now let's look at all of the denominators. I got a 1, a 2, and a 5. If I multiply all those together, I get 10. These are all factors of the leading coefficient. And this is essentially what this Rational Zero Theorem says. That if I have this polynomial function, then every rational zero has to have this form, p over q, where p is a factor of the constant term, and q is a factor of the leading coefficient. Okay, what you also have to realize, of course, is that these factors can be either positive or negative. So whenever you're listing them out, we always put a plus or a minus in front. Okay, so to help you remember this, let's look at a really simple case. Just a linear equation, y equals 6x minus 10. So let's say we're going to find the zeros of that. So I take the y out and I put 0 in its place and solve it for x. And of course I would add the 10 over and then divide both sides by 6. And simplifying, I get 5/3. So notice that the 5 is a factor of the negative 10 and the 3 is a factor of the 6. The 3 is on the bottom, the factor of the leading coefficients on the bottom, because at the end you have to divide by that term. So it's always on the bottom. And the 5, which is a factor of the constant term, is the one that's on top because you're just adding or subtracting that to the other side.